All right, let's get into it. For the last few years, the React Native team has been deep in the trenches on a massive project, completely rebuilding the framework's core from the ground up. So in this explainer, we're going to break down exactly what this new architecture is, why it was so desperately needed, and how it's poised to be a total game changer for building awesome mobile apps. Yeah, let's be real for a second. Anyone who spent any time with React Native knows exactly what he's talking about. It's always been powerful, for sure, but the old system had some, let's just say, fundamental flaws that held it back. And we're not talking about small bugs here. These were deep architectural skeletons. So let's dig in and meet the biggest skeleton of them all. You know, the root of almost all the old problems can be boiled down to a single component, just one word, really: the bridge. This thing was the communication highway between your JavaScript code and the phone's native UI, and man, was it the source of some major performance headaches. And this visualizes the problem perfectly. On one side, you've got the JavaScript world. That's where all your React code lives. On the other side, you have the native world, which is what actually draws the buttons and text on the screen. The problem? They couldn't just, talk to each other directly. Every single message had to get bundled up and shipped across this one single asynchronous bridge. And this trip across the bridge wasn't free. Oh no, it had a heavy toll. Every time you wanted to update something, even a tiny piece of text, your data had to be serialized, basically squished into a JSON string, sent across, and then deserialized, rebuilt on the other side. Imagine writing a letter, stuffing it in a bottle, and tossing it across a river. Then doing that hundreds of times a second. It's just so slow and inefficient. So to fix this, the team knew they couldn't just put a Band-Aid on the bridge. Nope. They decided to tear the whole thing down and build something completely new. This wasn't a quick fix. It was a huge multi-year effort that kicked off way back in 2018, all to create a solid foundation for the future. And this new foundation is built on three main pillars that all work together. First, you've got the JavaScript interface, or JSI, which is the direct replacement for the bridge. Then there's Fabric, a brand new rendering system. And finally, Turbo Modules, which is a much smarter way to handle native code. Let's see how these pieces come together. All right, time to pop the hood and see how this thing really works. We're going to look at each of those three pillars and see how they fundamentally change the game, starting with the big one, the replacement for the bridge. The JSI is the absolute heart of this whole thing. It's a super lightweight layer written in C++ that lets JavaScript talk directly and synchronously with the native side. If the old bridge was like sending messages in a bottle, the JSI is like having a direct, crystal clear phone line. No delay, no waiting. And here's the magic trick, the secret sauce that makes it all possible. The JSI allows your JavaScript code to hold a direct reference, a pointer, really, to a C++ object that lives on the native side, and the other way around. This idea of a shared reference completely changes everything, because now the two worlds aren't separate anymore. And as Theo puts it, this is just nuts. Because you have that direct reference, you can just call methods on native objects straight from your JavaScript. There's no more packing things into JSON, no more serialization bottleneck. That entire performance tax, it's just gone. Okay, so once you have that super fast, direct communication line from the JSI, what can you build with it? Well, that's where Fabric comes in. This is React Native's totally new rendering engine, and it is built from the ground up to use the JSI speed to make your UI updates incredibly fast and smooth. Fabric's power comes from its new three-phase pipeline. First, during the render phase, React does its thing and creates a tree of components in JavaScript. Then, in the commit phase, the layout gets calculated and the whole UI tree is prepared. And finally, in the mount phase, that tree gets turned into the actual, real native views you see on your screen. It's a multi-threaded approach that makes it way more responsive. And this slide is the perfect real-world example of what that means. Look at the left side. That's the old way. You see that annoying visual jank where the tooltip kind of jumps into place after you scroll? It feels laggy. But on the right, with Fabric, you can measure the layout and update the UI synchronously before the screen even paints. The result? Perfectly smooth motion. The last pillar is Turbo Modules, and this analogy just nails it. The old way was like going to an all-you-can-eat buffet. Your app had to load every single native module it could possibly need right when it started up, which made startup slow. Turbo Modules are more like ordering a la carte. They're lazy loaded, so they only get pulled into memory the very first time you actually need to use them. This makes a huge difference for app startup time. Okay, so that's a lot of complex engineering. But what does it all mean for us, the developers, and for the people actually using the apps we build? Let's talk about the payoff. Well, the proof is right here in the numbers. Just look at this benchmark. Rendering 5,000 components on an iPhone 12 is dramatically faster with the new architecture. We're not talking about a small improvement here. This is a massive leap forward in UI performance. And it's about more than just raw speed. The new architecture finally unlocks a whole suite of modern React superpowers that were just impossible before in React Native. I'm talking about concurrent features from React 18, things like use transition for silky smooth UI updates and suspense for way better loading states. This finally brings React Native up to speed with modern React for the web. And if you want to see the absolute ultimate stress test, look at this. The Vision Camera library can now process about a gigabyte of data per second, in real time, right from the phone's camera. This was flat out unimaginable with the old bridge because of that serialization cost. It's opening the door for a whole new class of apps that just couldn't be built before. Now, all of this sounds absolutely incredible, right? But it leads to the most practical, down-to-earth question of all. When and how should we, as developers, actually start using this? So here it is. The big question on every single React Native developer's mind. With all these amazing benefits, should you just drop everything and start migrating your production app right now? Well, the official guidance from the team is actually really clear and pretty sensible. For most production apps, the recommendation is to wait. Hold off until the new architecture becomes the official default. This just makes sure the whole ecosystem of third-party libraries has time to catch up. But if you're a library maintainer, they're saying, yes, absolutely, you should be enabling it now to get your code ready for the big switch. And this timeline really puts things into perspective, doesn't it? This has been a long, careful, deliberate process that started all the way back in 2018. The plan to make it the default by the end of 2024 shows just how mature and well-tested this is. It wasn't a rush job. It was a multi-year rebuild, and they're rolling it out with that same level of care. So in the end, this is so much more than just another update. It's a brand new foundation for React Native. By killing the old bottlenecks and enabling true, direct communication, the new architecture doesn't just make our current apps faster, it raises the entire ceiling on what is even possible. And that leaves us with a really exciting question. What completely new class of high-performance apps will this revolution unlock?